Yeah, in the last video, we have seen given pressure and the liquid phase composition, we found temperature, and of course, we can find Yi. Okay, these are known. Actually, these are known here, and these two we are finding. That means this is known as bubble point temperature calculations. And we have pressure and we have the vapor phase compositions. We found temperature and we found X. We can find Xi. This is known as, because we know all the vapor, this is known as dew point temperature. This is known as bubble point temperature calculation. This is known as dew point temperature calculation. This is what we have done in the last session. Now, a small change is that now in this case, we will say that we know temperature and we will fix or we will find the pressure. So we know temperature here. That means we know temperature and liquid phase compositions, and we need to find pressure and Yi. This is known as bubble point pressure calculations. And we know temperature and vapor phase composition. We will find pressure and Xi, and this is known as dew point pressure calculations. So this is the motivation for today's class. Okay, let me rub this all. Hope it is clear to you. See, suppose in a jar or in a small beaker, we have here. Okay, let me actually draw it correctly. See, we have in a jar or in a measuring cylinder or conical flask, we have acetone plus methanol, and this is total liquid, and we are heating, right? Total liquid means what? Its liquid phase composition should be known. That means X1 and X2. X1 is acetone composition, X2 is methanol composition. That is how it is. That means we know the pressure and what is the temperature at which the first bubble of the vapor forms. That is known as bubble point scenario. Okay, right. Now let's actually go to the next exercise now. Now today's exercise is that the same, composition, and see, and I've used a gas liquid separator here, but I am trying to actually, first of all, okay, let us go to this particular flash calculations here. And then input is known, output is known, and at what temperature and pressure it gets flashed, that we don't know, because either we are operating this particular flash equipment at a constant pressure or constant temperature. We should decide, right? So I go to the stream. Now, instead of taking pressure and vapor fraction as a flash spec, I take temperature and vapor fraction as the flash spec. And now, in this particular scenario, what do I do is that I fix a temperature, suppose say 40 degrees centigrade. Okay. I want to operate the flash vaporizer at 40 degrees. That means temperature is known as 40 degrees centigrade. And what is the, what is the compounds? That is also very important here. What is the mole fraction? Mole fraction is 60-40. See, that is very, very important. Even without our knowledge, we should actually understand that is very important here. So this mixture is fixed 60% and 40%. If it would be 50%, 50%, again the values, every value will change. Okay. Now at this particular ZXF or ZF feed composition, we are trying to solve. Now we know the temperature and the liquid phase compositions and we are trying to find the temperature now. Okay, we are trying to find the temperature. That means here, if you see, this is not temp. I have fixed temperature, and we know the temperature as 40 degrees centigrade, and let us make this as vapor fraction 0. That means entirely it is liquid now. Now check. See, whatever feed we have taken as 1 kilomoles per hour, as it is liquid, in the gas liquid separator, if you go to the top vapor, nothing will be coming out. It will all 0 kilomoles per hour. Only everything will be coming out as a bottom product which is liquid. So that is known as, that is what it means now. Now you see it is operating at vacuum. My goodness, operating a flash column at a vacuum is very tough. But still, okay. Now what happened is that we got two scenarios. One scenario now, temperature is known and Xi is known, that is 0.6, 0.4. And we found pressure to be as 0.543 atmosphere. So temperature and liquid composition, this is known as bubble point pressure calculations. This is number one. Okay. Now the other scenario is the temperature is fixed. Now whatever the feed we are saying, let us assume this to be as a vapor. Then if I find pressure, that is known as dew point pressure. Okay. For that, what should I do? I go to the vapor phase mole fraction here in this particular input window. That means this one. So I have to come here. So this particular area, again, you have to change this, keeping as it is. This temperature is 40 degree centigrade. I will change this. Then what will happen? Now, if I come to this place, if I take this as completely vapor now, completely vapor. Okay. This is completely vapor now. With the complete vapor, what is the pressure we are getting? We are getting pressure as 0.524. See? So bubble point pressure and dew point pressure is like this. Okay. So this is how we generate the bubble point pressure and bubble point temperature, dew point pressures given temperature and the composition. Okay. This is a short video on the dew point calculations, whether it is a pressure, dew point pressure or bubble point pressure. Oh, sorry. I should not say dew point, only dew point. It is a bubble point pressure or dew point pressure. This is pressure calculations. Okay. Right. We'll come back with another video where exactly there will be a, or rather in this only, this will be too long otherwise, we will see at what temperature, if I fix pressure, what is my dew point temperature, what is my bubble point temperature. If I know that, if I take any temperature between that, I will be getting a liquid plus vapor as the, what do you call, in the input stream. That means inside the flash tower, what is that temperature and pressure? What is that temperature and pressure? If I keep, there will be two phase forming and vapor phase coming out and liquid phase coming out. That is what is very important for us. Till now, we were focusing on either it is a bubble point temperature calculation or a bubble point pressure calculation, or a dew point temperature calculation or a dew point pressure calculations. But what exactly is required in the separation processes is that you want to flash it. So for flashing, you need to specify pressure and temperature as per the degrees of freedom. When it is done, and pressure and temperature as well, we have to give the compositions of the feed. When it is done, we will know how much can be flashed as a vapor and a liquid can be separated.